Hi, welcome to my video on review 1 on limits and continuity. This review is on the videos 1 to 9, and as in all reviews, this one can be marked out of 32. So give yourself a score for each question and total up the pages, or total up the page. And when you get them all done, total up all the pages and put it over 32. Here we go. Let's see how well you know the first video is 1 to 9. Find the value of each. The f of 1. The f of 1, x is 1. When x is 1, that means we have a 1, 2, 3. So we have a 3. And as x approaches negative 2, as x approaches negative 2, so x is approaching negative 2 on the, this is on the right side, or on the left side, it makes no difference. The f of x is approaching 2. So for each of those, give yourself a mark. The limit of 4x minus 1 as x approaches 2. So as x approaches 2, we sub it in. We get 8 minus 1, we get a 7. If you get a 7, give yourself a mark. There's no restrictions at 2, no vertical asymptotes, etc., etc. So we don't have to worry, just sub it in. Find the value of each. So we have a graph here, and this is the h of x, so the limit of the h of x as x approaches negative 1 on the right side. We're approaching negative 1 on the right side, so we're coming down here. That means we're on this part of the graph. So as we approach negative 1 on the right side, the y value becomes 3, negative 3, sorry. That's negative 3. And as we approach the h of x, as we approach negative 1 on the left side, so this is approaching it on the left side, that means we're coming down here, so the y value is 2. So if you get each of these right, give yourself 2 marks. Now we have a piecewise function, so as x squared when x is greater than 3, is x is equal to 3, it's negative 2. When x is less than 3, we have negative x plus 4. So the p of x as x approaches 3 on the left side. So the left side is less than 3, so that means we have a negative x plus 4. So we're approaching 3, so that means we have a 1. And this is the limit of p of x as x approaches 3 on the right side. 3 on the right side is greater than 3, so that's an x squared, so we put 3 in the place of x, and we get a 9. So if you get each of these right, give yourself 2 marks. So that's 7 for that page. Hopefully everything is going well, and you'll understand what the videos are about on limits. And we have a graph here, so we got, it says find each, find the limit up to k of x, so this is the k of x function, as x approaches 1 on the right side. So as x approaches 1 on the right side, this coming down here, we have the value of y. K of x is the y value of 3. As x approaches 1 on the left side, as x approaches 1 minus on the left side, we have the y value approaching 1. So if the left side and the right side are equal, then we have the limit, but they're not equal. The right side is 3, the left side is negative 1. So the limit at 1 for the k of x does not exist because they're not equal. The left and the right are not equal, so the limit doesn't exist. Number 6, we have negative 1 over x minus 2 as a function, and we're approaching 2 on the right side. Notice that we put 2 in. We have put a 2 in here. We have 2 minus 2 is 0. Negative 1 divided by 0 is undefined. So what that means is that at 2, we have a vertical asymptote. So as we have a vertical asymptote, that means the graph, as if x is going to infinity, this fraction goes to 0. If it goes to a negative infinity, it goes to 0. So what is 3 going to give me? Put a 3 in here, and I get 3 minus 2 is 1. Negative 1 divided by 1 is negative 1. So I have it this point here. So that means it's approaching 0. So it's coming along right here. And as it approaches 2 on the right side, this is the right side, it's going to negative infinity. If that was approaching 2 on the left side, it would be over here, doing this, going up here. And the closer I get to 2 on the right side, like if I had 2.5 plugged in, the number starts to get larger and larger. The closer I get to 2, the closer I get to larger, the y value becomes negative, coming down. Number 7, the limit of 2 over x plus 3 as x approaches negative 3. Again, the vertical asymptote is negative 3. So let's look at when we have a negative 3. So there's the vertical asymptote as x equals negative 3. And we want to approach, so if we take 1, so again, as x goes to infinity, this denominator gets larger and larger and larger, this fraction goes to 0. So as x gets larger and larger and larger, this goes to 0. So it's either going like this or going like this. So let's try a number. Okay, let's take a negative 2. Put a negative 2 here. We get a 1. 2 over 1 is 2. So negative 2 gives me a, let's say that's a 2 right there. So that means it's on this side. So it might be. Let's have a look at. So it's hitting here. So it's approaching infinity. So that means it's coming down like this. There it is, the vertical asymptote. It will not cut through the vertical asymptote. Horizontal asymptote is 0. And that means if I put in negative 4 in here, negative 4 will give me negative 1, which will give me negative 2. So negative 4 is negative 2. So this point here, so that means the graph is doing this. So as x approaches negative infinity, this fraction is approaching 0. So the further out I go here, the closer this gets to the y-axis. Sorry, the x-axis. There's the y-axis. Better be careful. There's the x-axis. So the left side is approaching, as you approach negative 3 on the left side, it's going to negative infinity. As you approach negative 3 on the right side, it's going to positive infinity. So those two one-sided ones are not equal, so the limit does not exist. And it's, even though it's undefined, but if the limit to the right is equal to the limit to the left, then that's the limit, even though it's undefined. Now, what about this rational function, 4x minus 1 over 3x plus 2, and there's no indeterminate here, no zeros. So if we sub in 3, so we get 4, 3 minus 1 over 3 times 3 plus 2. 11 minus 1, sorry, 12 minus 1 is 11. 9 plus 6, 9 plus 2 is 11. 11 over 11 is 1, so the limit here is 1. And again, if you have 3 of these right, give yourself 3 marks. If you have this one right, give yourself 1 mark. If you have this one right, give yourself a mark. If you have 1 here, give yourself a mark. And number 9, f of x. Notice we have piecewise function. So if it's greater than 4 is on the right, then we take this linear, 3x plus 4. If the number is on the left, we take 4x minus 1. So what we have to do, we look at the limit as it approaches 4, so we have to look at it on the left and on the right. So on the right, we get 3 times 4 plus 4. That's 12 plus 4 is 16. On the left, we get put 4 in. On the left is greater, or sorry, the right is positive,
and the left is negative, so we use it here. So that gives us 16 minus 2 is 14. And the right side, 16, the limit. The left side is 14, limit. And they're not equal, so the limit does not exist. The left is not equal to right. Total up your score. Hopefully you have 7. And don't forget, for each question you do, you can pause the video and work out the answer first before I do. That's a good way to do it too. At number 10, the t of x, we have a piecewise function, and it's when x is greater than negative 2, we have this parabola, x plus 1 all squared plus 3. When x is less than negative 2, we have this linear negative x plus 1. So which one is true? Which is true for the limit as you approach negative 2? So let's look at negative 2 right here. So if we look at negative 2 as, I'm taking, this is on the greater than, so greater than is approaching negative 2 on the right, so that's the right side. So that's negative 2 plus 1 is negative 1 squared is 1 plus 3 is 4. And we look at negative 2 on the left side, so we're looking at negative x plus 1. So it's negative 2, so it's the negative of negative 2 plus 1. And so that's 2 plus 1 is 3. So we have, let's see which is true. The limit of t of 1 exists? No, they're not equal. So this is no false. So as you approach negative 2, t of x, it does not exist. They're not equal, so this is the correct answer. So it's not equal. Yes, this is the right side equal to 4. This is the left side equal to 3. That's true, but they don't exist at negative 2. These limits are not the same, so B is the answer. And again, if you work each of these out, you get a mark each. If you've got this is your answer, give yourself 3. And what about the limit going to infinity? 2 over x. As x gets larger and larger and larger, 2 over x gets smaller and smaller and smaller, approaching 0. If you got 0, give yourself a mark. And what about we go to negative infinity here? So this is negative 3, and we're going to negative infinity. So negative times negative is positive, so it's 3 positive infinity plus 1. So the limit, that's 3 times a larger number, so the limit is positive infinity. And let me explain that another way too. Note that this is y could be written down this way in terms of y. So x is 1, that's the y-intercept is 1, and the slope is negative 3 over 1, so down 3, 1, 2, right 1. So this is the line. There it is. So notice as you go to negative infinity, as x goes to negative infinity, y is going downward, which is, as x goes to positive infinity, the y value is going to negative infinity. But we asked when x is going to negative infinity. X is going to negative infinity this way, so that means the y is going to positive infinity, going up. Better be careful. Give yourself a mark if you got infinity. And what about the limit of 2 as x approaches infinity? So let's look at the graph of that. So x is going to infinity, so we have 2. So 2 is right here. So there's 2, like that. That's y equals 2 is a horizontal line. So as we go to infinity, we have a 2. Because it's a horizontal line, y equals 2. Anywhere on that line, no matter if you go negative infinity this way or positive infinity that way, you'll have a 2. Give yourself a mark. Again, 6 for that page. Hopefully everything is going great. Let's continue. What about the limit of this rational function when x goes to negative infinity? So what I do is I look at the highest power as 1. They're the same. So I take each of the powers, each of the terms, and divide by x. If I divide each of the terms by x, so this is the limit as x is approaching negative infinity. So as we approach negative infinity, this becomes an 8. This is 1 over x. That becomes a 4 minus 3 over x as x approaches negative infinity. So what happens as we approach negative infinity now, we have an 8. Negative infinity, 1 over negative infinity approaches 0. Fraction is getting smaller and smaller. So therefore, we get a 0. We have a 4. Negative 3 over x as x gets larger and larger and larger, this fraction approaches 0. So that gives us 8 over 4, which is 2. So if you use this strategy of dividing by x and working it out to this right here, and you did this, so give yourself 1 mark for this strategy as it approaches infinity, and 1 mark for the 2 altogether. Number 15, what about we have the f of x equals x squared plus 3x divided by x minus 1. It says find the limit of the f of x as it approaches infinity. So notice the power on the top is larger than the power at the bottom. So if you divide each of the powers by the second smallest power, which is x, so I'm dividing each of these terms by x, and that gives us, let's continue, that gives us x plus 3 all over 1 plus, or subtract 1 over x. So as this limit, as you go to infinity here, as you go to infinity, this is infinity, this is the 3, that's a 1, and that's a 0. So we get infinity plus 3 over 1. So we get infinity plus 3. So the answer is, the limit is infinity. So as x gets larger and larger and larger and larger, the numerator gets larger, so it goes to infinity. So if you have this structure here, give yourself 1. If you have infinity, give yourself 2. Again, you can see that it gets larger and larger, and it's positive also. Now, next question is find all the asymptotes and find their point of intersection. Well, we have a vertical asymptote, x minus 1 equals 0. X equals 1 is a vertical asymptote because your denominator is not equal to 0. Also, it's the x squared. Let me look at it. The x squared is factorable as x outside of x plus 3 all over x minus 1. So I factored the numerator, but it can't cancel out. So there is, because it can't because the x minus 1 didn't cancel out, that means 1 is a vertical asymptote. Now, because the numerator power is larger than your denominator power, this is a quadratic and linear, I'm going to work out your, what we call the oblique asymptote. When your numerator has a higher power than your denominator, you will get an oblique asymptote. So let's divide x minus 1 into x squared plus 3x. So x into x squared goes x, multiply back. X times x is x squared. X times negative 1 is negative x. We're subtracting, so we make that a negative, and we make that a positive. So they cancel out. 3x plus 1x is 4x. Now, we have a 0 here. In descending orders, we bring down to 0. X into 4x is positive 4. Multiply back, 4x. Multiply back, negative 4. We're subtracting, so we make the positive a negative. Make the negative a positive. So they cancel, so that's 4. So what we have is that this function, instead of f of x we can change the f of x to a y, so y equals, this is your divisor, that's your quotient, this is your divisor, so this is your remainder. 4 is your remainder, so it's 4 all over x minus 1. So that's your quotient, which is the answer to this division. This is your divisor, which is your denominator, and this is your numerator. So if you took x plus 4 multiplied by x minus 1 and added 4, you would get x squared plus 3x. Now, what happens here, your oblique asymptote, is x goes to infinity. That means that this fraction goes to 0. So we have y is approaching x plus 4. So that's your horizontal asymptote. So your oblique asymptote is y equals x plus 4. And if you have the vertical asymptote, if you have your oblique asymptote, 2 marks, 1 mark for the vertical, 2 marks for the oblique, so there's 3 marks altogether, so total will be page out of 7. Okay, let's continue. Hope everything is going well. And I want to look at the graph of that function. So remember, the function had a vertical asymptote at x equals, put a little arrow, x equals 1. It had an oblique asymptote at y equals x plus 4. And I want to write down that function again. So we have the f of x is equal to x squared plus 3x all over x minus 1. Why did I write that down? Well, when we want to graph it, we graph the vertical asymptote x equals 1, so there's the vertical asymptote straight down through there, like that. So that's x equals 1 as the vertical asymptote. And the oblique asymptote is y equals x plus 4. So I've got a y-intercept of 4 right here. And the slope is 1 over 1, so it goes up 1, right 1. Or it can go down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. So this is the oblique asymptote, going like this. So this is y equals x plus 4. Now, that means the graph will, let's see, so the graph is either as 2 boomerangs, in here and here, or it's in here and here. And let's see. Remember, it goes towards the vertical, goes towards this asymptote. So it's either like this, or it's here. It goes along here, it goes up here, and if it goes along here, there it is. So let's find out where it is. Let's look at the expression. So we take x squared plus 3x equals 0. X outside of x plus 3 equals 0. So x is 0, or x plus 3 is equal to 0. So x is negative 3. So when what we're doing here, when we make we're saying that y equals 0. That means we're finding the x-intercepts. So when we make y equals 0, and when you make y equals 0, the numerator is equal to 0. So that means it passes through 0, x is 0, and negative 3. So we can see that it's coming in here. So it goes down like this, comes up, and so this is just a rough sketch. There it is there. Now it's in here. That means it should be probably in here. Let's check. Let's see where the other point is. Say, let's take x equals 2 and sub 2 in here. So the f of 2 equals 2 squared plus 3 times 2. X is 2, so it's 2 minus 1. So 4 plus 6 over 1. 10 over 1 or 10. So that means it passes through the point 2, 10. 2 comma 10 is, let's say, take an estimate to be about right here. So there's the point that it passes through. So it goes up. There's the vertical asymptote going up there. So it goes up here like this. And it comes. Now, where it bends, you have to do more calculus to find out where the bending is occurring. There it is. Goes through this point. So this point is 210. So that's a sketch of this graph, but it has a vertical asymptote and a horizontal, excuse me, vertical asymptote and a horizontal asymptote. And there's 5 marks for this question for graphing. So if you graph the 2 asymptotes, you get 2 marks. If you found out the x-intercepts, you get a mark. If you found out the y-intercept, and the y-intercept is 0. If you found out the other point and you drew the graphs like this, 5 marks in total. So that brings us to the end. So add up all your pages, add up all, and see what score you got. And whatever score you have, take your final mark, put it over 32, divide 32 into the numerator, get a decimal, move it 2 places to the right to get a percent. And again, like all tests, hope you got everything right and you understand. But that's the first review on videos 1 to 10. And again, if you like my video, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.